All right, so homework assignment was to remove front, remove end, remove an index. Okay, and it was pointed out to me that in our add index, we omitted one line of code. So here's our added index. What is it? This dot number of elements plus plus. In our else here, we weren't actually increasing the number of elements by 1. You need to make sure you only do it inside the else and not in this if and else, because these guys already, add front already increases it, add end already increases it. So if you did it in there or if you did it globally outside of the structure, you would add 2 for every 1 for adding to the front or adding to the end. Okay, that makes sense? All right, so let's write our methods. Well, let's write the easy ones first. If we are removing from the front, that is, we want to take this node, remove it from our list, and return that node. Well, what are we going to do? Well, the first thing we need to do is we need to maintain a pointer to this guy. Okay? So we're going to create a, well, we can use cur node, that's fine. Actually, I'm going to rename it. Node to remove. So we're going to create a variable called node to remove. And we're going to point this guy at the same thing head points to. That'll be step number 1. And somebody want to get the front lights? Okay, so this will be public node remove front. So the first thing we're going to do is we're going to create a node to remove, and set this guy equal to head. Okay, that's what we did right here. Then we set head equal to head's next node. Then we set node to remove's next node to null. So we no longer have that extra pointer pointing to that guy. Now we've disconnected it, we can safely return it. Correct? Now, in the special case, what if head is currently null? If we're dealing with the empty list and we try to remove from the front, we should return a null, correct? So if head is equal to null, return null. Otherwise, we'll still be kicking and we'll do all this crap. So this if statement handles our special case if you try to remove something from the front of the empty list. Make sense?
Why do you need to return anything?
What do you mean, why do you need to return anything?
Why do you have a node not void?
Well, because this guy expects us to return something.
Right.
If I don't have a node to return, I'm going to return the empty object, which is null.
What I'm saying is, why do you have a public node instead of a public void? What's the benefit of returning?
Oh, well, when you remove something from the front, you might want the element that you just removed. You can choose not to use it, but you might want to use it. We might say remove from front, now let's go and do something with the guy we just removed. So this gives us the option to utilize that. All right, remove front makes sense? All right, let's go ahead and test this guy. Oh, one thing we're missing. Number of elements minus minus. So we need to put that before the return statement. We will not do that in the case of return null, because we did not return an element. We did not actually remove anything. All right, so let's go test this in driver. So we have a bunch of crap in our list. Let me just display the list real quick and see what's in there. All right, so that's our current list. If we say remove front, we should get one returned to us. Node n is equal to ll dot remove front. Then we'll say ll dot display, which should be everything that used to be, but with the 1 taken off. So there's our new list with no 1 on the front of it. And n should hold the 1. So that called its toString method. Make sense? Okay, so that's remove front. What about remove end? Well, here we'll solve it over here. So if this is my current list and I want to remove from the end, that means I want to remove this guy. So what am I going to do? Well, if I'm dealing with the empty list, return null. So we'll do that same little quick litmus test. Public node remove end if tail is equal to null, which is equivalent to saying if head is equal to null, then return null. Otherwise, what are we going to do? Well, we're going to make node to remove point to the same place that tail points to. So I'll create a node to remove, and set this guy equal to tail. Then I'll make tail point to what? The guy before tail. How do I get to the guy before tail? What if the length of my list is 1? If the length of my list is 1, the guy I'm returning is actually what? The only guy in the list. So if I'm removing that one guy, I need to then set head and tail to null. Because I just made my list, my one list, the empty list. Does that make sense? Is the same thing true for remove front? Else if this dot length is equal to 1. So if I have a 1 list, then what am I going to do? Well, I'm going to create a node to remove, set this guy equal to head, set head equal to null, set tail equal to null, and return node to remove. That make sense? So that's if I'm dealing with the 1 list. If I'm dealing with the 1 list, And then I also need to reduce the number of elements. We're doing a little bit of duplication of code here, but that's fine. It keeps it fairly compartmentalized. So if it's the empty list, return nothing. If it's the one list, we will return the one element in that list, but we need to make sure we set head and tail equal to null, so that we in fact have the empty list after this is done. Otherwise, we'll do the normal thing. Same thing is true here in remove end. If it's null, return null. Else if this dot length is equal to 1. If we're dealing with the one list, node to remove is equal to, we can say head or tail, or we'll say tail. Then we'll set head is equal to null, tail is equal to null. Oh, so interesting question, Val. So are we just letting this computer reboot for indefinitely reboot?
I have no idea. That's very strange.
It's been doing it for 2 weeks.
I know.
Yeah, so I didn't know if at some point we're just gonna format it.
I think we're just gonna get rid of it.
What, is it really broken?
I guess.
I'm guessing it's just a software issue. Should be able to just reinstall the OS and everything should be fine.
Yeah.
Okay, so
Complicated.
yeah, something. So node to remove equals tail. Set head and tail equal to null. Set this dot number of elements minus minus and return node to remove. That's if we're dealing with the one list. Otherwise, if we're not dealing with the one list and we're not dealing with the empty list, we must be dealing with a list with at least 2 things in it, which means that we definitely have to walk to the guy before the current node. How do I do that? How do I walk to this node if I currently have node to remove pointing here? Because what do I need to do? I need to make this guy's next node point to nothing. And then I need tail to point, to point to this guy. That's what I ultimately need to do, correct? But I need to get to this guy first. How do I do that? Go ahead.
Walk it until this dot length is -2.
Okay, I could do that. Could I also walk it until cur node, if let's assume I say cur node, could I walk it until cur node's next node is equal to node to remove? So rather than do it on a count, I can say node cur node is equal to head, have it point to the front of the list, then while cur node dot get next node is not equal to node to remove, set cur node equal to cur node dot get next node. Won't this walk our list until cur node's next node is equal to node to remove? I'm just going to keep doing it until I finally get myself into a position where cur node points to a place that is node to remove. That is, I'm going to walk until I get right here. Right here. And I'll show you that here. So I'll start cur node off at head. Is cur node's next node equal to node to remove? Is it equal to this guy? Nope. So what are we going to do? We're going to set cur node equal to cur node's next node. Is cur node's next node equal to node to remove? Nope. Set cur node equal to cur node's next node. Is cur node's next node equal to node to remove? It is. So here's cur node. His next node points to the same place that node to remove points to. So is cur node where I want it to be? It is. So what do we do next? We set cur nodes next node equal to null. Oh. Last try, and then we're giving up. Okay. Cur nodes next node equal to null. Cur node dot set next node to null. What happened to Angela?
She wasn't feeling well.
Oh, I was like, wasn't she just here like 10 minutes ago? Cur nodes next node equal to null. Then we want to set tail equal to whatever cur node is equal to. Tail is equal to cur node. Then this dot number of elements minus minus return node to remove. That make sense? So after all is said and done, node to remove points to the guy we want to remove. Tail points to the new end of the list. The new end of the list points to nothing. Null. His next pointer is null. And cur node will die a natural death because it was a local variable of remove end. So that'll be the, well, and so is node to remove. So that's the new state of our, and we've been representing that with just nothing. It points to nothing. So this is the new state of our list after removing from end. Make sense? Let's test that. All right, here's our original list. The last node in the list is 12. Then we show the list after removing it. 12 is gone. And we should have the node 12 is the one we received. Make sense? Okay. So those are the two easy problems, right? Remove front, remove end. How many of you got these to work?
I missed a couple things, but
Ish.
I
Got these to work ish. All right. How many of you who got it to work drew pictures? Some of you didn't draw pictures. Why not? Did you get it working? Did you get it working?
Yeah.
How long did you spend on it? Go ahead, embarrass yourself.
Upwards of 5 hours.
5 hours. All because you didn't draw pictures.
The first two are easy. The last one was-
So now, those of you who didn't draw pictures, why didn't you draw pictures?
Would have taken more time.
Even after I told you to draw pictures.
I was doing my assignment in the middle of another class.
Doesn't mean you couldn't draw pictures. Whenever you're dealing with linked lists, draw pictures. It will help you. Every single line of code we wrote here, I mean, because this isn't a trivial set of code here. And there's plenty of things going on there. But every line of code that we wrote here, we first depicted in our picture here. Right? So it became paint by number. All right, so remove front, remove end. Now the friendly guy, remove an index. Public node remove at index. Int index. If index is equal to 0. What are we going to do? We're going to return this dot remove front. Else if index is equal to this dot length, we will return this dot remove end. Else if index is less than 0 or index is greater than this dot length, what are we going to do? And actually, this should be index is equal to length minus 1. When we were adding to length, that was acceptable. Okay, in our add at index. But remove at index, we can't remove something that doesn't exist. So we want to say if index is less than 0 or index is greater than or equal to this dot length. Well, this guy is going to throw an Amish exception. Didn't somebody text me with a funny Amish exception joke? I think so. Something about they shouldn't have used Amish exceptions because.
That was in my assessment thing.
Oh, what was it?
My computer didn't accept my answer because of Amish exception.
Heresy. That's right. Yep. Ha! Are your people going to sit there and take that?
Yes.
Ooh, Candy Crush. Hold on, I gotta play. What was I talking about? Oh, so this is our exception. So we will throw a new Amish exception. Can't remove index from linked list with length. Oh man, this almost sounds like it's serious. This dot length arrow smiley face KK thanks. Some exclamation points. All right. So we're going to throw an Amish exception. We're going to build a big old string. Can't remove index. Let's say they said -4. From linked list with length. Let's just say the length is 7. And an arrow, smiley face, KK thanks. That will be the exception that we throw. And this guy throws an exception, not throw exception. So it throws an exception, and this is where we throw the exception. Else. So if we're not removing from the front, we're not removing from the end, we're not removing from a place that we can't remove from, then we want to actually remove from the index. Okay? Well, how will we do that? Let's go to the picture. So let's say I want to remove from index 1. Well, first thing I need to do is I need to get to index 1. So I'll create my node to remove. And I want this guy to ultimately point to index 1. How do I get there? Well, start at the front of the list and walk to index 1. Correct? But what if, actually that we should be covered there. We don't need to check to see if we're dealing with a 1 list. Because if we're dealing with a 1 list, then end, it would have been covered by index is equal to 0. Correct? Okay. So, we just do the else here. So we're going to create node to remove. We'll start this guy off at head. We'll say for int I is equal to 0, I is less than index, I++. We know how many times we need to loop, right? We need to loop index number of times. And each time we're going to say node to remove is equal to node to remove dot get next node. Go ahead.
Would it be more beneficial to loop to index -1?
Possibly. Let's look at it. Right now, just let me walk to the place. So we're going to walk to the actual node. What he wants to do is he wants to walk to the previous node so that we don't need to walk again. Because if we walk to the previous node, then we can come here. Then we can set node to remove to this guy, so we'll need another pointer in any case. But let me just do it this way. That way it at least matches up to our other ones. And then I'll show you this other way. So we'll walk all the way to the node we want to remove. Then what do we need to do? We need to set this guy's, well, we need to set the previous guy's next node equal to this guy's next node. So we need to connect this. Correct? Okay, actually with that in mind, rather than just creating another stupid loop, let's just do them both. So let's say node cur node equal to head. And let's walk to index -1, as he suggested. We'll set cur node equal to cur node dot get next node. So cur node will point right there. Then we'll say node to remove is equal to cur node's next node. Node to remove is equal to cur node dot get next node. And that'll make things point this way. So we walked cur node to the node we want to remove -1. Then we set node to remove to cur node's next node. Then we want to set cur node's next node equal to node to remove's next node. Right? Cur node dot set next node to node to remove dot get next node. So cur node, we're going to set his next node to whatever node to remove's next node is. So now they both point to here. Then we're going to say node to remove, set next node to null. Now that's null. And then we're going to minus minus and return node to remove. This dot number of elements minus minus, return node to remove. So node to remove will get returned. That variable will then die a natural death. Cur node will then also die a natural death, but this guy still exists because he still has a pointer count of 1 because head still points to him. And now this is our list. So remove at index. Let's go test that. Let's do remove at index 3. So here's our original list. We had one, this is 0, this is 1, this is 2, and this is 3. So we want to get rid of the 9. Notice the 9 is gone here. and we retrieved the 9 down here. That makes sense? Okay, so that was your homework assignment. Questions about that? How many of you who did not draw pictures this time will draw pictures next time? Even though I told you to draw pictures this time. But you didn't want to embarrass yourself and said you spent 5 hours. Embarrassing yourself. At least you got it working. So I guess it was 5 hours of worthwhile work, right? Now, I'm not necessarily saying it wouldn't have taken 5 hours even if you had drawn pictures. But drawing pictures would have significantly decreased the debugging time. Because the second you start messing around with connecting up pointers to the wrong places, and you're not drawing pictures, that's going to be a very, very, very difficult problem to debug. Okay? So, draw the pictures. To be honest, even for a list like this, I would still draw the pictures. I mean, I'm not just doing it for my health up here. I could probably visualize it in my head and not have to draw the pictures, but drawing the pictures makes the problem really trivial. It's just connecting the dots. If I gave you a human being and say, okay, make this node get removed from the list and make sure everything still hooks up to everything, we all could solve that problem, right? Writing the code for it's a whole different issue. That's why we draw the picture, then write the line of code that's equivalent to the move we just made. It's a monkey see, monkey do thing. All right. Now, what would you say is currently a weakness of our linked list? We can add things. We can remove things. We can get things at specific positions. So could we store and retrieve elements of arbitrary size? I could just start putting stuff in my list, right? What are some weaknesses I have right now?
Can't change the payload.
Okay, right now the payload is of type int. Correct? Well, do we always want to store ints inside of our payloads? Or might you want to store a bunch of different kinds of things? All right, so let's store some different kinds of things. Let's say that instead of storing ints, we'll keep it simple. Let's say I want to store chars. What do I need to change in my code to make this guy able to store chars? Well, it's going to come down to how we add stuff to our list, right? Because adding stuff to our list is the point where we pass in our payloads. So added index, we take in an int payload. Add front, we take in an int payload. Add end, we take in an int payload. But now I want this guy to work for chars. So what am I going to do? Am I going to change each of these? How do I make this just work for a char? Well, I'll come in here and I'm going to say added index is going to take in a char payload. Add front is going to take in a char payload. Add end is going to take in a char payload. And finally, nodes get built using a char payload, and they store a char payload. Make sense? Come out to driver. Well, let me just do a bunch of adds. We know added index works. ll.add a. What was it? Add node? Add front. Well, let's just add end. We'll add the alphabet. Not the whole alphabet. First couple things of the alphabet. B, C, D, E. And then we'll display it. So there's our list containing characters. No big deal, right? Just made a couple of changes. What if I want my list to store ints and chars? Uh-oh. I need to store two different kinds of values? Great. How do I do that? How would you adapt this to store ints and chars? Go ahead.
You just make another, in node, you make another, you have a char, so you make an int, and then have it take in both a int payload and a char payload.
Okay, you're talking about in the node class?
Yes.
Okay, so you want to update node, and you want to have a second version of this constructor that takes in an int? Maybe I misspoke. I don't want it to store two payloads. I want it to store a single payload, and that payload may either be an int or a char. So I want to be able to hold A3B4. I'm not going to go any farther because I'm already confusing myself. So I just stored two chars and two ints in my list. So I want to be able to store both of those guys, both of those types of payloads. Not at the same time, but not a single node with two payloads, but a node with one payload, where that payload may be an int or that payload may be a char. What?
You make another constructor named node that takes in an int.
Okay. So we'll create a second version of this guy. And you want him to take in an int payload. Okay. What am I going to do with it?
You have to add another variable up top for a name.
Oh, you want me to have, so I needed another one of these. Private int, what do you want to call this guy? Payload 2 or something?
And you gotta change the node to payload.
So this dot payload 2 is equal to payload.
No. When you take, instead of taking in an int payload, take in a int payload 2.
Why? Well, this is just a variable name. I could have called this elephant. It doesn't matter what I call that guy. I mean, you probably want to have a decent naming convention, but whatever I call him here is just how I have to use him down here. So now my node. So you think we're done?
You have to set the next node to null.
Okay. Now we're done? What happens when I display this guy? Or what happens when I convert this guy to a string? How do I know whether I should use this dot payload or this dot payload 2? Because you're telling me if I have a node and I'm building the node with a char, well, then I'm going to set my payload variable, which is of type char, equal to the value. But if I'm building it with an int, then I'm going to set my payload 2 value equal to the int that was passed in. So now, this single node has two different payload values that at any time I'm only using one of those. Correct? So how does this guy down here know which payload I should be using? Right now, it's always going to print out the char version. Whether I created it with an int or not, it's going to print out whatever the default value of my char payload is. But I want nodes to be able to interchangeably hold two different payloads. Right off the bat here, we should start feeling pretty uncomfortable with the fact that a node is only supposed to be able to hold one payload at a time. But that payload may be either an int or a char, yet we've created two payload variables. So we've made our node to be able to hold two things at once. We don't want it to be able to do that. We want it to be able to hold one thing at once. But that one thing can either be an int or a char. So right now, we should be pretty afraid that we felt like we needed to add an extra variable up here. It's probably going down a bad path. Could we possibly make this work? Possibly. We might be able to set a Boolean value in here asking which of the payload variables did you set. You know, so the Booleans may be true if you set it with a char and false if you set it with an int. Then down here you ask the question, if it's true, then use this dot payload. If it's false, then use this dot payload too. So you probably can make it work. And then what's my next statement going to be? My next statement is, what if we want to hold three different kinds of values? An int, a char, and a float. Well, now Booleans don't work. Now you got to go to some like special use integer. Well, if the integer is currently 0, that means we're using payload 0. If the integer is currently 1, we're using payload 1. If the integer is currently 2, we're using payload 2, and so on and so forth. Probably not the most elegant way to solve the problem. So how do I make my list able to store as many nodes as I want, where each node holds one value, where that value is either an int or a char? Go ahead.
Change payload to object type.
Okay. So we'll get rid of this payload 2 dealy. And you want this guy to be an object? Okay. Now what?
For the char, you can initialize it as a this.payload equals parentheses char payload.
So like this?
Yeah.
And this guy, you want it to be parenthesis int?
Yeah.
Like that?
Yeah.
How could I hold a char inside of an object? What are chars? Chars are primitive types, right? What's an object? Not a primitive type? It's actually going to hold a memory address here, which isn't the end of the world. This isn't the way to pull it off. But we're heading in the right direction here. He wants to change our payload to an object type. Well, what kind of object type? Well, right now we have it as a generic object. That's not going to give us very much flexibility, right? Could we make our own objects? Payload object? Okay. So let's go ahead and let's create a new class. We'll call this guy a payload. And we'll make this guy an abstract class. Everybody take out a piece of paper. Half sheet should be plenty. Okay? So make sure you get your name on it. Tell me, what does the abstract keyword do? Secondarily, tell me, why did we make payload an abstract class? For what reason would we have done that? So, what does the abstract keyword do, and why did we make payload an abstract class? Thirty more seconds. All right, let's have them. Oh, good or bad?
Terrible.
Terrible.
I think so.
How many times have we talked about that?
I don't know. I can't remember it
I
at
don't
all.
recall ever talking about it.
Oh, yes, we have. We absolutely have.
I don't ever recall talking about it.
Not this semester, but we've talked about it many times. Many, many, many times. What's the abstract keyword do?
Anybody answer the question?
That would be interesting. I have a feeling as soon as I tell you the answer, you'll remember us talking about it.
Boy.
Nobody knew what the abstract keyword did? When we make a class abstract, it means we cannot create an instance of that class.
Okay, I still don't remember.
Are you serious?
Yep. I don't remember it.
I don't think we talked
I don't
We
remember.
had to have talked about that last semester.
about it. We did not.
No.
Really?
We didn't.
There's just no way I didn't talk about that.
We didn't.
So let's say, how many got it right?
Well, actually, that's an interesting question. There's definitely a distinct difference between the number of people got it right and the number of people that answered my question. Because we typically have poor voter turnout. Did we really not talk about that?
You can look through the answers, and if no one.
Well,
got
no.
it,
Well, just I mean, the fact that everybody's being an idiot that's not proof that we didn't talk about it. Those are two separate things.
Maybe it's professor error.
No, it could be, but I doubt it.
I guess we have to stop and look through all of the videos.
We would have talked about this last semester when we were talking about creating your own objects. We were talking about inheritance. We were talking about sometimes you want to create an object that you never intend to create an instance of. Nothing.
Not in my 250 notes. Not that would automatically mean we didn't talk about it, but
Why is it in my head?
There's a
because
lot
you
of
teach
things.
multiple classes.
Yeah, but that 250 would have been the class that this would have come up.
Multiple versus 250.
I think this might be a big conspiracy for you guys to get out of this quiz. Okay. I guess let's add this to the notes. So I should throw these out, is what you're saying?
Yeah.
Should just read it for fun. Just like,
Yes.
ignore it all.
Did anybody happen to guess right? Man, I really don't think it's possible I didn't talk about that. That would really shock me. Abstract. An abstract class is a class that we cannot create an instance of. So if we write our own objects, typically we're writing our own objects to create instances of them. Why would we ever create an abstract class? Why would we ever create a class that we don't want to make an instance of? To support inheritance. That is, we might have a human being. Now, a better example might be a car class. So we have an automobile class. And we don't actually want to create automobiles. Instead, we want to create instances of cars and trucks. A car is an automobile. A truck is an automobile. Okay, so we cannot create the generic automobile. But we can create cars, which are automobiles, and we can create trucks, which are automobiles. And all automobiles have some common thing in common, right? There's some level of commonality between all automobiles. But then cars have something in common with other cars, which is different than trucks. Trucks might have different towing, tonnage, and crap like that. Okay, so the idea is you might make the top level class abstract because it's there to support the inheritance model for your cars and your trucks. So you put everything that's common to both inside of automobile, make that abstract, and then have car extend automobile and have truck extend automobile. Still none of it ringing a bell. Really? Jeez. It's very depressing for me. That means I actually have begun losing it.
Just realizing this now.
I mean, it is true that I do teach a lot of programming classes, so you know, it's possible I talked about it in one class other and not another, but I don't know, that's a topic that should have definitely come up in 250. We talked about objects in 250, didn't we? Like, we wrote objects, correct? We wrote our own objects. Like, we didn't have like a dice roller and crap. We never talked about abstract. Oh my gosh. Freaking incompetent up here. Well, it's a good thing I asked that quiz then. I would have just passed right by that keyword. Okay, so that's what abstract is. Make sense? So why then did we make payload abstract? It's because I do not ever want to create an instance of a payload. Instead, I want to create other things that are payloads. For instance, an int payload, a char payload, a boolean payload, things that are payloads. Does that make sense? So, the payload class is a generic thing. And actually, I'm not going to put anything in this class yet. I'm just going to leave it as an empty class. And I'm going to come out here. And we're going to create a class called int payload. An int payload is what? Well, it's going to have a private int payload. We will create it, public int payload. Let this guy take an int payload as a parameter. This dot payload is equal to payload. Okay, now for getting the payload, for commonality's sake, why don't we have all of our payloads get returned as a string? Remember, Java is a string-based language. So anything, if we can get something in the form of a string, we can probably get the value out of it. So we're going to write a method, public get, public string get payload. And this guy will return the empty string concatenated with this dot payload. Make sense? So that's the contents of our int payload. I'm going to steal most of this code. And we're going to go and create a char payload. And this guy is going to house a private char payload. Constructor is called char payload. We'll build it by passing in a char payload. And we'll return the empty string followed by this dot payload. Make sense? We're going to say that both of these guys extend payload. Extends payload. Which is our abstract class. All right, that makes sense? Again, notice payload has nothing in it. We'll come back to this later. Is it a safe assumption if we didn't talk about abstract, we also didn't talk about interfaces? At the very least, probably not. That's more common. Sometimes interfaces don't come up, but it shocks me that abstract didn't come up. Okay, but in any case, we'll come back to this. Right now, payload has nothing in it, which should seem kind of mysterious to us. But in any case, we have two different types of payloads. We have an int payload and we have a char payload. Well, what we're going to do here is in our linked list, we're going to come up here and we are going to change, in our node, we are going to change our payload to be of type payload. That make sense? Change our payload to be of type payload. We will have our two different constructors. If we take in a char payload, we will say this dot payload is equal to a new char payload, passing it payload. If it's an int, we'll set payload equal to a new int payload, passing it payload.
You have elephant and stuff right here.
Oh, thank you. That makes sense? So, depending on which of these constructors gets called, I have two constructors with a different number and or type of parameters. What's that called? Polymorphism. So, depending on which of these constructors gets called, I will create either a char payload or an int payload. Now, char payloads and int payloads are both payloads. What does that mean? It means that our nodes, our linked list, is a collection of generic payload objects. Where payloads come in two flavors currently, an int payload and a char payload. And both of these guys have a method called getPayload. Does that make sense? Okay. So that's what a node is right now. Now for display, instead of saying this dot payload, we will say this dot payload dot get. What didn't I call it? 1 second. Oh, it's actually interesting. Okay. This is going to expedite my my position here. I want to say this dot payload dot get payload. That's what I want to say. The issue here is that my top level class payload does not have that method. Well, I can come in here and I can say, okay, we're going to make a public string get payload method. And I can return, if you are seeing this, something bad has happened. With some exclamation points on it. All right, so this is a method called getPayload that takes no parameters, returns a string, and I'll just, for the sake of I have to return a string, write something in there. My intention is this guy should never get called. Why? Because both of my children have overridden that method by writing their own version of getPayload. Does that make sense? They've each written their own version of getPayload. But from Node's perspective, since at compile time, it sees payload as being an instance of the generic payload. Even though we happen to know it'll either be an int payload or a char payload. It'll be one of those two guys. But since we know, but as far as Node is concerned, it's a generic payload. We can always only call stuff that are inside of generic payload. So we'll call this dot payload dot get payload. Now, what else do we need to do in here? Doesn't seem like much. For creating nodes. Out here in our linked list, what do we need to do? Well, we probably need to update some of our methods. right now all of our add methods take in a payload. So what we're going to do is we're going to update these methods to take in a payload object. Okay, so that guy's going to take in a payload object. This guy's going to take in a payload object. And this guy's going to take in a payload object. Then we're going to write helper versions of each of these methods. Public void add end, and this guy will take in an int payload. And what will he do? He will call this dot add end, the one that takes a payload as a parameter, and we'll pass this guy a new payload, I'm sorry, a new int. It's capital I. A new int payload, passing it payload. So this guy's a wrapper. He's the one that will actually get called. Okay, add end, passing in an int. Internally, we'll wrap that inside of an int payload and call our add end. So we're actually going to make this guy private, so he can't be accessed externally. Okay. Similarly, we're also going to have another version of add end that takes in a char payload. And this guy will create a new char payload and pass it on to add end. So add end is going to take in a payload as a parameter, either a char payload or an int payload. That make sense? Which means what? Back here in Node, we no longer need to take in a char or an int. We actually only need one constructor in here. That is a node that takes in a payload called payload. Okay? Because we're doing the wrapping external to this guy. All nodes are built using a payload. And I'm creating my payload out here in linked list. So depending on which version of add end I'm calling, I'm either calling the add end passing in an int, in which case I created int payload, or I'm calling the add end that takes a char, in which case I'm building a char payload. In either of those cases, they will call add end. And what will add end do? What's this guy complaining about? I must just need to save it. There we go. Add end takes a payload object as a parameter. It's going to build our new node out of that payload object, do all of its magic, set all of its crap. Does that make sense? We're going to do the same thing for our add front. We'll change add front to be a private method. Then we'll make some public versions of add front. Public void add front. This guy will take in an int payload. And he will say this dot add front, the one that takes in a payload, and the payload will pass it as a new int payload built out of payload. Alternatively, we will have a version of add front that takes in a char. And this particular one will build an instance of char payload. Okay, add front takes in the payload object, builds our node out of it, does its magic, blah, blah, blah. Lastly, added index. We're going to make this guy private. Create a couple of public methods. Public void add at index. This guy's going to take in an int payload and an int index. And what will we do? We will call this dot add at index, the one that takes in a payload. The payload will pass it as a new int payload, passing it payload, as well as our index. Oh, this guy throws an exception, so we need to also have this guy throw an Amish exception. And we had to do that because the guy we're calling throws an exception. Similarly, we'll have a version of this that takes in a char payload, and this guy will create a new char payload and call the private added index. Make sense? Finally, actually get returns the nodes. That's fine. All right, so this should work now for all of our different types of nodes. So we'll go ahead and add an A. We'll add a 1. We'll add a C. We'll add a 2 to the front. And we will add at index and E at index 2. And then we'll display it. So we're adding integers and we're adding chars. Go ahead and run this. We have a 2, we have an A, we have an E, we have a 1, we have a C. That make sense? Now, somebody remind me what we're going to do when we come back on Tuesday is we are going to come into payload and we're going to see that this guy is really useless except for the fact that we're able to treat things as generic payload objects. So we're actually going to look at this guy. We're going to create a new version of him. Instead of him being an abstract class, we're going to make him an interface. Okay, so remind me to talk about interfaces. I'll actually create a new slide called interface. And that's what we'll start on Tuesday. Make sense? All right, I'll see everybody on Tuesday.